we established that we need to do some sort of iterative process. We can't just handle one hit and call it a day. We can't be that lazy, unfortunately. We need to be a little bit more generic. It's actually quite easy to get stuck in general as well. I'm gonna talk about it later. But okay. So we want to handle a case where we're sort of going into two walls in one frame. So instead of doing like one sweep, then if it's blocking, redirect and do another sweep, we're instead gonna do a sweep, check blocking, and then loop. So we're gonna essentially do this part as many times as it needs to until our full delta is depleted. So that's what we want to do. So I'm gonna for loop this. So I'll do or for loop. I'm gonna while loop it. So I'm gonna while our delta to move is nearly 0. So I'll do while it's not nearly 0. So while we still have delta left to move, we are gonna loop. Oops. There we go. Okay. So while we still have delta, I'm gonna do just a comment here. Iterative delta solving. So while we still have delta left to move, we're gonna sweep, check the hit. If the hit is blocking, we remove delta. The delta we just moved, remove that. Actually, we're gonna do this always. So I'm just gonna go ahead and just put that here. So like, no matter what happens, we always remove delta from the thing. Then we do collision handling. So we check if it's a blocking hit, then we redirect the velocity, and we redirect the delta. And then I'm gonna remove this. So what's gonna happen now is that if we have a blocking hit, it's gonna delta to move. It's not gonna be 0. It might be 0 if we hit a wall like straight on, and it just flat out removes everything. Like it removes all the delta. There is no perpendicular delta left. Then we wanna still quit. Then it's like there's nothing left to move. Just quit anyways. So it might be 0, it might not. But either way, we're gonna remove some delta. Cool. So yeah, let's see what happens. I don't see how this could go wrong. This is right. So if I get into this weird angle here, where I'm sort of going into the walls at once, let's see what happens. Alright, it seems to work. So now I'm actually sliding against both of the walls. So I'm like going on this one, then I'm sliding up on the other one, and also I'm going back into the corner like that. So that seems to work just fine. However, I conjecture that there's a way for me to crash this game. Because what's one case that's sort of like, can you see a case where this will break?
Coming at the wall in a perfect perpendicular angle, perhaps?
That should be fine, because if I'm doing that, then this here, this constraining to the wall, should actually remove everything. So when I've removed everything from the delta because I'm hitting a wall perpendicular like this, then this check will become false and I will exit the while loop.
One thing I'm noting is that you're removing delta moved times hit or time, even when it's not blocking hit. Won't that just be 0 or like unallocated memory? Or like
unallocated memory.
Because like if you don't hit when you sweep, what's that return?
The time is 1.
Oh, okay, never mind. Cool.
Good observation though.
Mm-hmm.
You should always ask those questions. Because maybe it isn't. Maybe I'm wrong. The one case we have not taken in consideration is when we're stuck in the wall. Because when we're stuck, hit the timer will always be 0. Because it's gonna say that we are stuck in a wall. It's gonna be a bool that's like start penetrating. And it's gonna say like, we're stuck, we hit something immediately, time 0. And no matter of redirecting our deltas or redirecting our velocity, it's gonna get us unstuck from the wall. So that means this while loop will just go on forever. Because it will trace, see that, oh, we're stuck. Remove some delta, remove some velocity. It will never remove all of the delta probably. Might do. Maybe it will. It's up to luck, I guess, if it happens to remove all of the delta or not. But in the end, it might get us stuck in this loop. So let's see if we can get that to happen. Because one easy way to get ourselves stuck in the wall is to just turn into it. Because when we turn, we're not doing any collision checking. We're just turning the box. So, if we turn the box into the wall, then the next frame, when we start moving, we're going to be stuck in the wall because we have turned it into it. So we're going to be clipping into the wall. So let's see if we can get that to happen. Oops. Fucked up. So I will go and I will turn into the wall. There we go. And the engine froze. Nothing I can do. Because what's happening, if we go into Visual Studio and just break, so I'll just hit the pause key here, it will just break wherever it is in code. Okay, this is in some, okay, so nice, we're in the game thread. So I'll just go into tick here, and we can see we're stuck in this while loop. So if I look at hit, not everything is actually false. Oh, wait, where are we? Oh, I think we're in the trace actually. Okay, so let's break here so we can just take a look at what's happening. So I'll just 5. What? Revert. No. What? Visual Studio, what did you do? Please let me control set this. Okay, thank God. Okay, so I'll use the break here. Don't sass me, Visual Studio. Okay, there we go. So hit the wrong key. Fuck. Okay, so there we go. So if I keep moving here, now I should be able to check the hit. And yes, okay, so now we see start penetrating is 1. That means we're stuck in a wall. We have a blocking hit, but we're start penetrating. Time is 0. We didn't move anything. So we're stuck. Like, our normal is going to be something, but it's unfortunately the normal is not parallel with the velocity or the delta. So it's going to just keep taking away the same normal. Because when we're penetrating, the normal is actually the direction of the closest depenetration. So whenever the start penetrating is true, that means the normal is the direction we want to go in to get out of being stuck. And this penetration depth is how deep into the object we are. So that's like, we need to move away in the normal direction by 0.2 units to get out of this stuckness. But the main point is here that, okay, we are not handling this case. If we get stuck, like even with the penetration, which we're going to implement in a second, even with that, sometimes you're not guaranteed to get unstuck. And then it's important to get out of here in case something goes wrong. Like maybe our math here is a bit wrong, we don't remove delta properly, and we get stuck anyways, even though we're not penetrating. It's always good to cover your back and make sure that this iteration cannot go out of hand. It can only iterate for so many cycles. So what we're gonna do is I'm just gonna shift F5 because we can't get out of this. So it's closed editor. And I'm gonna make an iteration counter. So I'll just make an integer here. So it'll be like iteration count. It's gonna be equal to 0. I'm gonna make a const integer to be like max iterations. So we're saying we can only do 5 iterations or something. Yeah, let's say after 5, if we're not done after 5, we consider that something has gone wrong. We only expect like 2 or 3, maybe 4 if we're unlucky. So I'll do if delta to move is not nearly 0 and that's the wrong button. I hit F5. Fuck. Shift F5. Come away. Okay, well, whatever. Just do a thing. So if delta to move is not nearly 0 and iteration count plus plus is less than max iterations. Like so. So now it will keep going. If delta to move is not 0, but only for 5 iterations. So if this will keep counting up for every loop, and once it reaches 5, it will quit anyways. It will just get out. And then we want to maybe do like, okay, I want to get like a message or something. I want something to happen if that happens. If we get stuck, I want to know, and I want to be able to debug what happened. So I will just ensure here. Have you guys heard of assert before?
Yeah, I think they covered that.
Yes.
Previous C++ course.
Yeah, so assert will check an expression, and if it's false, it will, debug break or show a message or something. Something will happen to let you know that the expression was false. So it's sort of like, oh, this is supposed to be true. Please let me know if it's not. So I'll just ensure that iteration count is less than max iterations. So we want it to be that iteration count should never be or above max iterations, because then something has gone wrong. So let's see what happens. Got some Red Bull. Because we're gonna go fast, right? We're gonna go fast cars. I thought it was inappropriate. Appropriate.
I'm just jealous because I only have Trocadero.
Trocadero, what the fuck? Trocadero is like top tier. That's like SS tier soft drink, dude.
Yeah, but it's not as energizing. It don't give you wings.
I guess that's true.
You get a like shitty umbrella.
Shitty umbrella. Wow, that's a sick shade on the Trocadero business. Yeah. Okay, so now if I get stuck here, we should be breaking in code. So let's see. So I'll just go into the wall and then I'll just turn. Yeah. So this broke here. As in the debug broke. So we can see, okay, iteration count was 6, which is weird. No, yeah, okay, I did this wrong. It should be ++. It won't matter, but at least it won't be like more. It doesn't change anything, but it's nicer to see like an iteration count was 5. Not that we did 5 iterations, but it said 6. Anyways. What am I doing here? Oh yeah, okay, yeah. So we're stuck. We can check the hit and we can see, okay, start penetrating was true. So we can clearly see what the reason we got stuck here. So I'm just gonna add up the penetration case. So if we get stuck, I will handle that. So I will try to depenetrate. So I will do B, start penetrating. So if we're blocking hit and we're start penetrating, then I won't actually, I won't change the velocity and I won't change the delta. I will keep those the same because it's sort of a special case. And instead I will just move the car out of whatever we're penetrating with. So we're stuck inside something and I just want to get it out and move on and like continue from there. So I'm just gonna do a, I'll make a vector. That's the depen vector. So that's gonna be vector that depenetrates us from whatever we're stuck inside. And that's gonna be equal to hit normal times hit the penetration. Penetration depth. I'm actually gonna add a little bit of wiggle room in there as well. So I'm not gonna only do penetration depth. I'm actually gonna add a little bit. So I'm gonna add 0.01. This is 0.1, just to be safe. Just to make sure that when we are depenetrating, we are like sort of trying to make really sure that we get out of it. So this is how you calculate the depenetration vector when you're stuck in something. You just take the normal times the hit penetration depth. This will always be 0 if start penetrating is false. So this value is only valid if we are actually started penetrating. And then I'm just gonna add an active world offset of that depend vector. And I won't sweep, like we don't want to check for collisions here, we just want to get out and live our life. So I'm just gonna add a vector offset and then move on. So I'm actually gonna continue here.
You said that the hit.normal, if you're stuck in something, is the closest direction out, right?
Yes.
Okay, cool. Just making sure.
Because when you're stuck inside something, there's not really one impact location. Because when you're stuck with something, then it's like this whole surface that's overlapping with the other surface. So there's not really one impact point. There's like multiple ones, and there's not really one normal either. So that's why they're just sort of reusing the normal vector to be like, okay, it's not the hit normal, because there is really no hit normal, rather it's just the direction to get out. So that's like what they're defining to be the normal of the hit, even though there is no real one normal. So now, hopefully, if I get myself stuck here, so I'll just go into the wall and then turn. It seems to work. So I got pushed away a little bit from the wall. So maybe if I go a little bit faster. You see that? How I'm like pushing myself out of the wall by turning into it. I go a little bit, take a little bit more speed. I'll do full screen as well so you can see a little bit better. So if I take some speed, go fast, and I slide into the wall, and then I turn into it, you can see that I get pushed away from the wall. And that's the deep penetration doing its work. That's deep penetration. Every time I'm turning myself a little bit into the wall, so it's pushing me out of it. Then I'm getting a little bit inside the wall, and it's pushing me out again. So I'm like slowly inching my way out of the wall by turning into it. So that's deep penetration working is fine. So that's cool. Oh, I hit the guy. Fuck you, but okay. Not very satisfying. Cool. So that's it. That's very basic iterative collision solving. Also, I guess maybe we could call it like integrate. Oh. Oh no. All right. So this is a thing.
I'm sorry. What?
This wall is not straight. As you can see, it's slanted. So when I went into it, I actually rode up on the wall. So that's interesting. So I can be like, "Fuck you,
infinite
cruel
angular
world.
slopes.
Bye." Oh, it actually broke. Yeah, because we're going into the third dimension and we are not actually sort of handling. Whoops. We're not sort of handling third dimensional movement yet, but it kind of works. So we could probably make a ramp actually, and it would maybe work fine. We will be swimming in the air, but that's cool. Let's see. Let's make a ramp here. See what happens. Yeah. So
I have to go. My planet needs me.
Oh, whoops. So yeah, there he goes. Bye bye.
What happened to the friction? Like, why doesn't it like slow down?
Can anyone tell me why isn't it slowing down?
Oh, friction is only on the plane.
Gravity.
Well, yeah, we're only applying friction on the perpendicular and the parallel velocity. We're not applying friction anywhere else. So that's why it just keeps going upwards. The velocity pointing straight upwards will never get zeroed. So let's add some gravity. I didn't want to add jumps, but hell, here we are. So I'll just add gravity as well. So I'll just do...
I'm sorry, you didn't want to add jumps? Are you like allergic to fun?
I thought it would be too complicated, but it's not that hard actually. So we just do it. So let's do f vector up vector times minus what's a good gravity value? Maybe like 800, maybe. I don't know. Yeah, so we'll add gravity of minus up vector. Again, negative up vector is down. So we add add this to the list of forces here. So let's add plus gravity. And hopefully this doesn't fuck with anything. Because now, like, they are kind of swimming above the ground here, and I did this on purpose to make sure that we never collided with the ground, right? I never want to be a collision here, like it's sliding along the ground. But now that we made our iterative collision solver, I should actually be able to handle that. It should be able to handle slightly sliding on the ground and still going forwards. So it should work fine. So if I play now, I didn't compile. Oh yeah, failed? You fucking kidding me? Oh, whoops! I actually removed some stuff here on accident. Wait, I actually removed quite a lot of stuff. Okay, let's just undo. There we go. Okay. And let's write this again. Gravity. Yay. F vector, up vector, times minus 800. Then add it here. There we go. Okay, let's see. So now this should be like flat on the ground, right? Guess you can't really see. Let's see, I'm just gonna make the box not hidden in game. And yeah, they look like they're like flat on the ground right now. So that's good. So they fell down a little bit when we started the game. And if I go... Alright, seems to be working just fine. So I can still go, I can still collide with the wall. And let's see then what happens when I go up this ramp. So I'm gonna just line myself up here. Let's take some speed and let's go. And oh no. That's not good. So I think we got stuck in the other car. Ignore. Yeah, okay, I got myself out. Okay, so gravity is maybe a little bit strong. 800 was maybe a bit too much. I can't even overcome gravity to get up this fucking ramp. So that sucks. So let's ease up on gravity a little bit then.
Also, like, you're losing a lot of your velocity, right? If it's pointing upwards, likely.
Yeah, because then on this slope here, let's see. Like on this slope here. Hello? Yeah, okay. So on the slope here, as the car is going upwards, the force of gravity is going straight down. But as it's pushing us down onto the ramp, that velocity will actually be converted through to a little slightly backwards velocity. Because it will take away the part that's pointing towards the slope. So it will take away this part. And then we're left with the force going downwards. It's slightly less, but it's still a force. So that's why the gravity gets sort of converted into backwards force through our redirecting of velocities. And that's why apparently now this is way more it's way more force than our little tiny engine can handle. So we're gonna have to ease up on gravity a little bit. I'm just gonna do let's do 100, I guess. Oops. Maybe that's better. Let's try. So let's get some speed. And let's go. I didn't go well. Had you guys on the edge of your seats, right? Okay, let's go. So I'm gonna gather some speed. And let's go. And alright, so it worked. I would say gravity maybe a little bit low now, so it's like we're gonna float, which is not perfect, but hey, it works. It's something. It's like first pass gravity. You can also turn in the air, which is kind of weird. So probably we should remove acceleration completely while you're in the air, because the wheels aren't touching the ground anymore. But cool. So yeah, we technically have jumps. Can I still write up this one here? Wait, hold on. I can turn. Yeah, I can't. Oh. Kinda. Damn it. Alright. So that's collision. So now we have some basic collision handling in our game. And I think this is gonna be enough for what we are trying to make. So I don't think we really need to go much deeper into collision handling, honestly. I think this works just fine. Let's tweak the moving a little bit before we finish today. So I want to make the car feel just a little bit like it's not on ice. I want it to feel like we're on the road and driving a car and not like a hover bike or something. It won't really take any new movements techniques or anything. I'm just gonna tweak the values of the friction and the acceleration to make it feel more correct. So I'm gonna start by upping the friction quite a bit, especially on the perpendicular end. So I'm just gonna up this to like 5 or something, to really make sure that if we're not going forwards, we stop in that direction. We could have probably made these expose these, so we can tweak them here. Let's actually do that. I'm saying like, oh, that would be a good idea. Too bad we don't like good ideas here. Let's do it. I'm just gonna make those viewpointers. So I will make a category for these actually. So I will make a category called car physics. And then I will make those edit anywhere. So I'll make a float. Whoops. And I'll call it acceleration. I'll have that. And that's going to be equal to 200. You know, I love hard coding as much as the next guy, but I guess everyone has their limits. I'll make a few of these. Then we'll make parallel friction. I'll call it acceleration value, because acceleration is a vector. Force, I don't know, value, whatever. Strength. And then it's going to be parallel friction coefficient. So I'll call that well, when we had like parallel was like 1.2 or something, I think.
Wasn't it 0.9?
Yeah, it was. Let's make 1.2.
Okay.
It's gonna be better. And then we'll make what is the other one called? Perpendicular friction coefficient. I'll call it 5.1. There we go. So now we can easily tweak those from blueprints, and we don't have to recompile everything. So that's cool. And I'll just replace all of these. Acceleration strength. This is parallel friction coefficient. This is perpendicular friction coefficient. And bada boom. Maybe we should have made gravity as well. Whatever. I'm too lazy. So we'll compile this. Okay. So let's see how it feels with the new coefficients then. So now when I turn, Okay, so it feels a lot more like a car at least. It goes much slower. But at least I'm not like slip and sliding around. It'd probably be a little bit higher actually. So I'm just gonna go into the car blueprint here. And tweak those values. So I'll set perpendicular, I'll do 6.5 maybe? I'll put a little bit more. A bit more friction on the perpendicular side. There we go. So now I'm turning in a nice arc. When I'm turning, like I'm roughly going where the nose is pointing. I'm not like slip and sliding. So that feels pretty good.
Quick question.
Yep.
On your property, so you can, as you did just now, create a new groups, and so like car physics, where you can set all text and all. I wonder, is it possible to maybe change the color of the text on the group or on the properties of that, or can all only be white?
No, only white, and thank God. I would hate it if there was like different colors and it was like a fucking rainbow, like everything trying to grab your attention. So no, and I will quit Unreal if that is a feature. So no, you can't do that.
Or you know, if all the default already built-in properties so kept the white color, and you just made your own custom ones into a different color, more easily tracked like that.
Yeah, and then it would be like, oh, I have like 5 different colors for 5 different values. Good idea, but no. So I'll do 2 for the parallel. So we stop a little bit slow, a little bit faster. But now we're going god slow, we're like snail's pace going forward. So I'm actually gonna up the acceleration a little bit. So I'll up the acceleration to maybe 500. Let's see. Whoa! No. Alright, so now we're going a little bit faster. Whoop, sorry guy. So cool, now it feels a little bit more like a car and less like a hover bike. That's cool. I could probably tweak the frictions a little bit more and so on, but this will work for now. This will work for our car as it is. Doesn't have to be super tight. And if I jump out, bye bye. Ow. No, fuck you, no. All right, any questions?
Yeah, actually. So in your ensure in the while loop, I don't really understand why that hits, because it wouldn't be incremented if it goes into because it breaks out of the while loop, right?
Where?
Your while loop is dependent on iteration count being lower than max iterations, right?
Yep.
And then you ensure that it is again down there, right?
Yep.
So how is it bigger? I don't understand.
Well, the case where this will fail,
Yeah.
is the case where this is true. Because if we are plussing the iteration counts, and that is all of a sudden equal to or greater than max iterations, then we're finishing the while loop, right?
Oh, okay. Yeah. So we're not stuck in the while loop, but we're breaking out of it not because the velocity is nearly zero or the delta to move is nearly zero. We're breaking out of it because of the other part.
Yeah, because we're stuck in some way and something has gone wrong.
Yeah, that makes sense.
Cool. All right, any other questions? Cool. Crystal clear. So I'll upload this project. we have a lot of stuff to do. Like we want to make like checkpoints or something. We want to make a goal so we can finish the race. Might want to make the camera a little bit more fun. Maybe have the camera like in Smash Bros. That the camera is like following the two players but keeping them both on screen or something. Maybe have like boost paths that you can go over and then go like a little bit faster. Maybe even like shoot guns or something. Maybe you could do like a battle royale mode where you like picking up guns and shooting each other. Could be fun. So yeah, we have a lot of stuff that we can do. Until then, so we have now Fridays off, Mondays off, because that's Easter. So Wednesday next week is the next lesson that we have. So I'm gonna set as a goal that we sort of finish something with this, like we do a little racing game or something, like you can play multiplayer or something like that. So that's gonna be my goal, and then I guess we'll see how that goes, but hopefully it goes well.
Sounds great.
Yeah, sounds
Thanks.
Sweet.
Thanks a lot.
No worries.
Happy long Easter weekend, everyone.
Yeah.
Yeah, have a
Same to you.
good Easter, guys. Stay
Good
safe
luck
and
finding the eggs.
eat eggs or something, whatever you do at Easter. All right,
Take care
guys.
of yourselves.
See ya.
Yeah.
Bye
See ya.
bye.
See you.
Take care.
Bye.